Okay. Now, again, there are sometimes expressions which don't fit in your table, in your integration table. So, for example, something like this. You will see there is nothing like this in your table. So, what should you do? We will learn some other techniques. So, it could be that you can apply one of those new new techniques, but for now, knowing what you know at this time, what you should do is manipulate this expression in, or the manipulate this is called the integrand. Remember, manipulate it so that it looks like it becomes familiar. It looks like one of the table, one of the rule in the integration table. So if you recall, sine over cosine is tangent. So I can rewrite this expression inside as sine of x divided by cosine of x times cosine of x, which means I can write it as sine of x over cosine of x times 1 over cosine of x dx. Note here, we can write it like this because there were two cosine x's here being multiplied in the denominator. If I had cosine x plus cosine x, I cannot get it to this form. So now we can rewrite it as, first one is tangent x, and the second is 1 over cosine is secant x. Does that sound familiar? If you know your derivatives, you should know this is the derivative of what function. Did you get it? I mean, like, you can always go back, look in the table, but eventually you have to kind of know it. So this is the derivative of the secant x. So the entire derivative of this quantity will be secant x plus c. Next one is then this is something. This looks like a product of secant x and this expression. Now, sorry, I have changed the variable here. So we can have different variables or different. The important thing is that the d of it should have the d of that variable that is in your integrand. I mean, if I put dx here, you cannot integrate it. You cannot write the integral, okay, entire derivative, because this dx is saying that integrate with respect to x. Well, there is no x here. So either there is a typo if you see something in the exam, or so there is something wrong. So keeping it the same way with the theta, what can we do? Since this is a product and we don't know the product rule yet for integration, so what will we do? Distribute. So if you distribute, you get secant theta times secant theta, which is secant square theta, plus secant theta into tangent theta d theta. Now again, if you separate them, you get secant square theta d theta plus integral of secant theta times tangent theta d theta. Now the first one is secant square is the derivative of tangent. So the antiderivative of secant square will be tangent of theta, and then plus, we all just did that one. This is going to give us secant of theta plus c, and that's your answer. Looking at the next example, what do you think? What should we do? Distribute, right? Because we don't know the product. What do we do with the product here? So we can write it as integral 3 to the t plus 3 to the t times 2 to the t. And then we have dt. So which is equal to integral 3 to the t remains as it is, but what happens to the second term? How can we write the second term? Sorry, this term. So if you recall, one of the properties of the exponents is that if you have same power and bases are different and their terms are being multiplied, then the bases get multiplied. So we will get plus 6 raised to the power t, and then dt. So if you distribute integral 3 to the t dt plus integral 6 to the t dt, which is equal to 3 to the t over ln of 3 plus 6 to the t over ln of 6 plus c. Okay, what about the last one here? So can I do this? Sine cancels with sine, x cancels with x, and I'm left with 2 dx. Is that correct? No, no way. These are not being multiplied. These are functions. You cannot do this. So then how to simplify it? Well, again, you have to recall your stuff from Calc 1. It's actually trigonometry. So you can write the sine 2x as 2 sine x cosine x all divided by sine x dx, which is going to now sine x will cancel with sine x. So this will cancel with this, and we are left with 2, which I can put outside the integral, and inside we have cosine x dx. Now what is the antiderivative of cosine x? It's sine, we know, but will it be positive sine x or negative sine x? This is something you have to remember, because sometimes students make a mistake here. So 2 just stays. Antiderivative of cosine x is sine x plus c. That's simple. So how can you remember this? Remember what are the derivatives? The derivative of cosine is negative sine, and the derivative of sine is cosine, positive cosine. So you have to, or you can also think of it like this. The antiderivative of cosine, if you say is negative sine x, now differentiate this, so you should get back that. But if you differentiate the negative sine x, you get negative cosine x, which is not what we have on the left side. So it means you have to write positive sine x. So this is how we do the integration, or the indefinite integral. Okay, now we are going to do definite. Okay, now again here, how will we solve this one? Well, if you recall, if you have again by algebra, you have a plus b over c, you can write it as a over c plus b over c. So this is what you should do here. So you can write it as integral of u to the 1/2 over u squared minus u over u squared du, and the integral is going from 1 to 4, which is equal to now integral from 1 to 4. Now we simplify the power. So what I get here? I have 1/2 minus 2, which will give me negative 3/2. So I have u to the negative 3/2 minus 4. No, sorry, this was u over u squared. So I have 1 over u. And then du. Okay, now I will do the antiderivative of this quantity, which is going to be u to the negative 1/2, because when you add the negative 1 to negative 3/2, so you add 1, you'll end up getting negative 1/2. So I have u to the 1/2 divided by 1/2 minus, now what is the integral of 1 over u? Ln of u. So ln of absolute value of u. And then I have 1 to 4. So apply the FTC part 2. I will plug in the limits. So this will go up. It will come 2u to the 1/2 and minus ln of u will stay like it is, and then limits are from 1 to 4 is equal to. Now first I plug in the 4. So I get 2 times 4 to the 1/2. This is actually what? This is actually square root of u. So if you want, you can write here 2 times square root of 4, or you can write it as 4 to the 1/2 power minus ln of absolute value of 4. So this is the upper limit minus the lower limit. What is the lower limit? It's 1. So I get 2 times square root of 1 minus ln of absolute value of 1. Now note here, we don't need the absolute value in here, or that we plugged in. We don't need this absolute value, we don't need this, because, or you can say the absolute value of 4 is 4, so, and absolute value of 1 is 1. So applying the condition, so I get, I'll just simplify. So I'll 2 into square root 4. Square root 4 is 2, and then we have 2 here, so we get 4 minus ln of 4. 4 minus ln of 4, and then I have minus 2, and then I have plus ln of 1. Ln of 1 is 0. So I have 4 minus 4 minus 2, which is 2, minus ln of 4. Now note here, we can simplify ln of 4 as 2 minus 2 ln of 2. Can you think why I can write this? Again, you have to recall the properties of logarithm. Next example. B is over here, so let's go down here. So I have 1 minus sine square t over sine square t. Again, remember, can we do it like integral of the top divided by integral of the bottom? But no, we cannot. And also, if you notice, this will not be, if you see integral of sine square t, that is something we don't have in our table. So we need some other, and we have no, no knowledge of how to, you guys don't have the knowledge to how to do this yet. So what else can I do? Well, the stuff that we have been doing until now. Split it. So pi over 4 to pi over 2. I can write it as 1 over sine square t minus sine square t over sine square t dt, which will be equal to, so integral pi over 4 pi over 2. Now 1 over sine square t. Do we have something like that in our table? You don't see like something like that, but I am seeing this one, cosecant square x. So isn't this what we have? 1 over sine is cosecant, so 1 over sine square is cosecant square t. We have cosecant square t, and this is 1 minus 1 dt. Now it became simpler. So we can now say this is equal to the integral of cosecant square t, which is negative cosecant t. And the negative 1 will be negative t. And then the limits are from pi over 4 to pi over 2. So now I plug in the limits, first the upper limit and then minus the lower limit. So I have a negative secant pi over 2 minus pi over 2 minus negative secant pi over 4 minus pi over 4. Need more space. And move this one over here, and then I should be able to write the answer here. Yeah, so what is cosecant of pi over 2? Well, remember cosecant is 1 over sine. So if you want to know cosecant of pi over 2, you can figure out what is 1 over sine of pi over 2. Sine of pi over 2 is 1, so 1 over 1 is 1. So I get negative 1 minus pi over 2 minus negative cosecant pi over 4. Remember, it will be 1 over sine of pi over 4. What is sine of pi over 4? Root 2 over 2, or you can say just root 2. So sine of pi over 4 is equal to square root of 2 over 2. Or this is equal to, if I rationalize the numerator, multiply both top and bottom by square root of 2. Why would I do that? Because remember, we are trying to find cosecant of pi over 4, which will be 1 over sine of pi over 4. So if you do it this way, you can still get the same answer. 1 over sine of pi over 2 will be 1 over square root of 2 over 2, which will then become 2 over square root 2, and then you can rationalize the denominator and simplify the answer. So it's your choice how you do it. Let me do it this way so you can understand what is happening. What I do here is I rationalize the numerator, because remember it's 1 over cosecant. Cosecant is 1 over sine, so square root 2 will be in the denominator. So we will have to rationalize anyway. So here I am getting 2 divided by 2 square root 2, which gives me 1 over square root 2. So now if sine of pi over 3 is 1 over square root of 2, then cosecant of pi over 4 will be square root 2 over 1 or square root 2. So negative square root of 2 minus pi over 4. So here now we can write it as negative 1 minus pi over 2 plus square root of 2 plus pi over 4. So negative 1 plus square root of 2, we can write it like this. Then now we can combine these. So this will give me negative pi over 4. That will be your answer. So one more and then I will stop. And next thing is, so here, how do we do this one now? I think we did this one in the indefinite integrals. So this is, we write it like pi over 6 to pi over 4. We distribute. So we secant of theta times tangent of theta plus secant square theta d theta, which is equal to, which gives you, you can now just anti-differentiate. So we get secant of theta plus tangent of theta and then limits. Plug in the limits. Secant of pi over 4 plus tangent of pi over 4. Now you should know these values. You shouldn't be plugging them in the calculator and finding, because calculator will give you decimal values which are not accurate. You should know the accurate values of these strict function. Okay, so this is one top limit minus the bottom limit. Secant of pi over 6 plus tangent of pi over 6, which is equal to, now secant of pi over 4 is same thing as what we got the secant of pi over 4 earlier. So this will be square root of 2 plus tangent of pi over 4 is 1 minus, okay, secant of pi over 6. How do we figure that out? Well, remember, sine of pi over 6 is 1/2. So cosine of pi over 6 will be square root of 3 over 2. So secant of pi over 6 will be 2 over square root of 3. Now I already wrote this, so you can easily from here figure out what is tangent of pi over 6. It will be sine over cosine. So it will be 1/2 divided by square root of 3 over 2, which makes it 1 over square root of 3. When you rationalize this one, we can write it first and then do rationalizing. So this will be negative secant of pi over 6, which is negative 2 over square root of 3, then minus 1 over square root of 3. We can combine these two. So we get square root of 2 plus 1 minus 3 over square root of 3, which actually can be simplified by rationalizing this one. So we end up getting square root of 2 plus 1 minus square root of 3. That is the answer. So this is how we do the definite integral. Let's stop now.